All right, so what I'm going to do, this is 129S, and we're down here at here. So we're going to talk about client-side controls, and then I'll demonstrate command injection in the Web Security Academy. And I may, if you have enough time, I may demonstrate new API CTF I've got, but I might put that off till next week. So let's start with the slides, and that's going to include a demo of Burp. All right, so if you have controls trying to limit what people do, but they're on the client side, then they're running on the user's browser, and therefore the user can get around them. So, and another issue is very common here. It's very common for the server to send data to the client, like a cookie, and then the client keeps sending that data back to the server. And yet that cookie is important, and developers typically assume that that data is reliable. And of course it isn't, because anything that comes down to the client can be modified at the client side. So why would you do it this way? The usual reason is really just sort of disorganization among the servers. You might say it can improve performance because you're not storing a lot of data on the server, like everything in a shopping cart. That's true, but I don't think that's the big issue. I think the big issue is that you have many different servers, and they were designed for another purpose. And if you are the developer developing one app, you probably can't easily get the other servers modified to meet your needs. So you have to just accept the other services being the way they are. For example, one common situation is you already have a web app on a web page for your company, and someone says, add a mobile app to our company, but you aren't allowed to change anything about the web app because that's what most of our customers are using. So you have to design the mobile app to somehow get along with the web app. So that means the easiest way to do it is to have all the data bounce to the app and back to the server and back to the app and back to this server. So you have all the cookies for all the different services all sort of mixed together. It is usually the easiest way to get the job done is to keep putting all the data back on the client with shopping carts and such, because just of the disorganization of companies. So let's take a look at hidden form fields. This is a really simple vulnerability. So if you go to, I should have the Burp browser someplace. Well, I should have the, right, somehow I don't have the Burp, I must have closed it by accident, all right. So, all right, and then it's hidden.htm. All right. So here's a page where you can buy an iPhone. If you buy one iPhone, it says, okay, you bought one for $449, and your goal is to buy it for $50. So I'm using the Burp browser. So that means I can see the requests inside Burp here. And you'll see how this is easy to do. If you go to history and go to the end, here's the post that bought a phone. So you can examine it down here, but I'm just going to send it to the repeater. That's the easiest way because you probably want to modify it anyway. And now you can see the request. So it's a post request going to this page, and it's got a bunch of headers, and then it's got data, quantity, and price. So it is sending the price from the client up to the server. And so now this is something that might be harmless if its price is just there so the user can see it, but it's not actually used on the server. This would be fine, but in fact, if you change that price to a smaller number and send it, then the response says, you did buy it for $4. So it's taking the price from the client and believing it on the server, and this is a common mistake, a very simple one. All right, here's another one. If you click here, you'll get a discount. Now you can buy one with a discount of 10%, or perhaps 10. All right, so I got a discount of $10. And so if I look here, I go back to my proxy. Here's the post that sent that one up. Now, when I did the GET, let's take a look at each of these. The GET request, I sent a request to the server, and then it sent a response, which set a cookie, I think. I guess I'm not seeing that happen here. And let's get rid of this garbage. Anyway, maybe it was this one. This is the one that set the cookie, set cookie.php. Okay, that response set this cookie. It set a cookie that says discount equals 10. And then when you did a post, that cookie was sent back up to the server with discount equals 10. So it's the same thing. These are all going to be essentially the same thing. If you go to the repeater, this request sends data to the server telling it I want to buy one object at $4.49 and I want a discount of 10 up here in the cookie. There. And so I can just make the discount 100 and send that. And now I will, if I render the response, there. Now I got a phone with a discount of 100. So same kind of thing. These are all working with the same kind of problem. I think I'll just go through them here because these are, so here's another one. If you buy a phone here, 1, and submit it, now it puts it right up here in the parameter. Quantity equals 1, price equals $4.49. So you can do that. It puts it right up there in the get field. That just, of course, makes it very easy for the user to just lower that price, and now the price is lower. So here's one where you use the referrer. So I'm going to buy a phone, but I'm not allowed to. I can only get it if I get it from apple.com. So I have to modify the referrer. And so once again, I can do that in burp. If I go to the proxy and I find the get, this is the one I think that lets you render it. No, that was the one that loaded the page. Here, let's just clear all this old stuff. Clear history. And then do this again. There, I buy one now. Now that's what I want to do is look at this request. All right, that's the request. This is the one that failed. So I want to send that one to the repeater. And, all right. And so here you can see the referrer should be in here somewhere. There it is, there's the referrer. And the point is, it's coming from my site, and it has to come from Apple in order for you to get a discount. And so you have to change this to apple.com. And then send it. And now you get the phone with the discount because you appear to be inside the company. You know, that's why you can't trust referrers, just like you can't trust the from address in emails, and you can't trust the number in phone calls that says where the call is coming from, that the police use to send SWAT teams and cops and such. Both of those are easily forged. Yeah?
You can do that on phone call?
Yeah, you can go online. There's things, you make a phone call and you can make the caller ID be anything. You can make it appear to come from the White House, and people use this for swatting. If it's somebody you don't like, you call the police, you change your caller ID to be their house, and you say, I've got a gun, I'm going to kill the hostages. And then they'll send a SWAT team. People can get killed this way.
Some calling app, phone call app?
Yeah, you can do it. You need basically a proxy for phones, and there are websites that go to it. They'll do it for free, and there are paid services that do it. A lot of telemarketers do it to make the phone appear to come from someone you might answer and things like that. Yeah. It's, by the way, an extremely serious crime, swatting, anyway, but people do it. Usually young kids for pranks because it doesn't benefit anybody. Anyway, then there's a length limit, so I'm trying to buy 10 phones. So I can buy one phone, and it works, but if I try to buy 10, I can't type, the 0 has no effect. And the reason it has no effect, if you examine the data here, I can inspect this, and what if I make that bigger? Yeah, I can, good, all right. Then down here, there's a table, and table body, table row. I may not be able to easily find the, all right, let's try source. I sort of hate this nonsense. View source. There's somebody who used that inspect thing if you're better at it than I am, but I always get lost trying to find things in there. Here's the field where I'm sending quantity. There's quantity. And, oh, here we are. It's using this validate page. So here's the validate page that checks to see the quantity. If the quantity is greater than 5, alert quantity too large. So this is a script called validate form, the form. And the form down here where you put in the quantity has action is hidden one. There's going to be a reference to that, validate this form in here somewhere. Oh, I got to find the right one. I see. I'm getting this whole page. I need number 5. Okay, so number 5 is here. There we are. And now, just this one here just has max length equal 1 right there. So when you have a field like this, an input field in an HTML form, it can only take 1 character. So That would look bad, but of course, you can simply override it in burp. The post is sent here, and this is the one that buys one phone. If you send it to the repeater, you can change it outside of the browser. So the browser limited it to just one character, but I can now change it out here to 10 and send it. And now I bought 10 phones. So the validation done on the source, there's just many different ways to do validation on the source side. Can you override it in the browser's source code? Yes, you can. In fact, let's do that. I'm glad you bring that up. Now that we're here, I could also just do this. I could go in here and modify this. At least I can with some versions of the browser. And so I need the developer tools. I think if I can get here with the inspect, I can get to the thing you can modify. 5, okay, it should be in here somewhere. Buy an iPhone, price, yes. Form, in this form, I should be able to modify it here. Usually you can. Maybe not in this browser. Nope, I think I did. Let's see. Wait, I deleted the whole thing. There we go. There we are. Now I think I still did 2. Max length equals 1. Yep, delete that parameter. That should do it. Now I should be able to do it right here. Yep. Yep, so that's another way to do it. You can modify the code right there if you go through the inspect feature, and I think there are other ways to do it too. Good. All right, and then there's script-based validation, the one I was just pointing out. This one, number 6, if we look at the code here, let's see if I can do this one with the inspect, which would be more fun. Okay. For some reason, it doesn't zero in on the right area at all. So inspect is not as helpful as I hoped it would be, but it's number 6. All right, here's number 6. And there's the table. There we go. That's a disabled field. All right, 6 should be up here somewhere. Boy, I thought the inspect would go there, but it doesn't. All right, now here you go. So on submit, return validate form. So when you hit the submit button, it will call the JavaScript function validate form, and that's up at the top in the head section. That's validate this form, and that makes sure the quantity is not greater than 5. So when you try to buy something, if you buy 2 of them, you're okay. But if you try to buy 6 of them, then it pops up this box saying quantity too large, and it doesn't send the signal. So there are a bunch of ways to fix this. You could turn off JavaScript in your browser. You could modify the JavaScript code in the browser. You can modify this field in the browser, or of course you can modify it in burp on the way out. All these will do it. You can, yeah, all right. And so the most direct way to do it in burp, of course, is to go to the proxy history and find that request, post to hidden 6, and send it to the repeater. And here, again, you've got the quantity that's 1, but I can change it to a bigger number now because I'm past the browser. JavaScript will no longer run to validate it. And now I'll get the response saying I bought 122. So, all right. And there's one more cute trick here. Why is this not moving? Try going back maybe. All right. And this one here, this is a disabled field. I can buy one, and the price is $4.49, but I can't change that field. Now you can then see why that works if you go to inspect, and now I think it actually went to the right place. Yep, now this field is disabled. You can have a field which just lets the viewer see it, but it's disabled, which means you're not allowed to click in here and change anything. And you can take the disabled off here, or again, you can change it in burp on the way out. And there's another cute trick in burp, which let me get to my slides. All right, we talked about these things. By the way, if you have responses from the server which come down zipped so you can't read them, then you remove the accept encoding. In your request, let me go to my burp request here. Here, if I go to my repeater and look at the request, okay, up here I have accept encoding gzip deflate. Now, in this demonstration here, I didn't have that problem because for whatever reason, the server decided not to zip this data. But it could have, and then it would be hard to read the data. So if you want to make sure you get plain text data, you just delete that line entirely. And then it will always give you plain text responses. The browser automatically lets it zip things to make it smaller and faster, but when you're doing manual tests, you might want to turn that off. And here, you can also automatically use match and replace in the proxy options, so it will always remove that, except encoding. You can get it to always remove that line. And there's something else you can do. I'm going to show you in a minute. It's even better. So we talked about the discount amount and the URL parameters. And so you can have lots of URL parameters. By the way, you can put them in things that it's not obvious. You can put them in images. You can put it in an iframe. This is more tricks of cross-site scripting. If I can inject this code in something your browser renders, it will then make this request in order to load an image. So this is often how you trick people into doing this. You find a vulnerability where you can do cross-site scripting, and you add code to the page, which goes to some other site, and now you can trick people into buying your product just from viewing a page. And there's a lot of ways to do that. And we talked about the referrer header. People might believe it, but there's no reason to believe the contents of the referrer header. It can just be modified by the client like everything else. Now you might find, however, that there's data that's opaque. It can just be a long random number like this. And that is better, right? I can't easily change it like I'm changing these prices. And so if you know how the opaque data is, that's called opaque data, where it has somehow been scrambled. So it's hard to read, but there is data in there. Now, if you know the plain text and you know the opaque data, you might be able to compare them and find the algorithm. You might be able to find a function in the app that will encrypt data, like it might be that your username appears with the same scrambling, and then you can just choose different usernames and get it to scramble things for you. You can, of course, replay it without deciphering it, as long as they didn't include something like an anti-CSRF token to make it unique every time, which you can do, but people often don't think of that. And then you can attack it with things like special characters and values that are too long and things like that to try to defeat the opaquing routine, and I've done that before. One thing I learned from your textbook that I've done quite a lot on Android apps is you make a password that has 32 A's in a row. And when they encrypt it, if they use electronic codebook, you will see 2 identical blocks of 16 characters being encrypted. And that tells me what algorithm they're using, and it's a weakness. But anyway, ASP.NET has the ability to create serialized data. And this is, if you really want to have data that's sent to the client and then comes back to the server and you want to trust it, then you use an advanced feature like ASP.NET. ASP.NET is Microsoft's scripting language, and you can add, yeah.
Right now people using ASP.NET Core.
What's that?
Right now people using ASP.NET Core.
Yeah, I think it's part of .NET. I think it's part of .NET. What's that?
View state is outdated.
It's outdated?
Yeah.
It could be. Yeah, what's the new one?
Right
.NET.
now we use .NET Core.
.NET Core. Yeah, but I think it still has this feature, but I'm not sure. Anyway, it's a good question. Actually, let's see. Does .NET Core have the view state?
It's called web page.
It's called web what?
Web page.
Web paste?
Page.
Web page, yeah. Let's see, .NET. .NET has something. Is it called view state? Not anymore. View state is a very good point. Okay. Yep, ASP.NET view state. And yeah, I don't know what they call it in, it's ASP.NET. Yeah, I don't know. It looks like people are still using it. But I don't know what the other product is. The other product is what? .NET Core?
.NET Core.
As opposed to ASP.NET. All right, .NET Core. Nope, okay, session and state management in .NET Core. Okay, they do have something comparable. State management, session state temp data, storage approach, cookies, session state, query strings, and session state, sounds like here's session state. Storage of user data, good. So this is a way to persist data across requests from a client. It's backed by a cache and ephemeral. Session state provides a cookie that contains a session ID. And I wonder if it is hard to modify. That's what I'm looking for. For limited time, there's no default mechanism. They aren't marked essential. Well, it doesn't sound like that's the same thing. Well, I don't know how that compares. But anyway, the product that I know about is this one. And this one here used the view state to add data to it. And then the form you get will now have this thing called view state that is just a long base 64 encoded thing. And the view state is base 64 encoded. Now, the default view state, if you don't put a signature on it, it's not protected. It's just base 64 encoded, so you can base 64 decode it and see the price just sitting right there. And so you could easily still modify it. But you can use MAC protection, and that will put a 20-byte keyed hash at the end, so now nobody can modify it. If they modify it, the hash won't match. And this is important, and this is the modern way to do it. If you want to send data to the client, you use one of these structures with a signature, or keyed hash, so it can be, you can tell it hasn't been modified. There's a Burp Suite add-on that will just open the view state and let you see all the data inside there so you can modify it. So you'll see the price right in there so you can change it. And all right, anyway, so we talked about the length limit and defeating it. And if you get a 304 request from a server when you reload a page while doing testing, this means it has been told not to reload this page because it hasn't been modified. So you can, you may see a header in there like if modified since, where the request will say only load the page if it's been modified. Otherwise, don't reload the page because I have a current copy in my cache. So you can remove this if modified since header to force a refresh, or you can use shift refresh. All right, and then there's script-based validation, what we just did. And you can defeat that with burp or the other ways. All right, so if JavaScript is used, you can try sending data that would have failed using a proxy to see if it's tested on the server. If multiple fields are validated, you can break the rules one at a time in each field to find out which ones are actually also validated on the server where they need to be. So client-side validation should be understood not as a security measure, but just a way to improve the user experience so they don't waste their time submitting data with like a misspelled phone number or something. But you can't trust anything done on the client. You have to revalidate it on the server. And here's the disabled field we saw. All right, so you can add the parameter, you can insert the disabled field in burp, but the really fun way to do it is use burp response modification on the options, and I'm going to show you this. This is the way to blast it all away. If you go into the proxy, and then proxy settings, and then you have response modification rules, you can unhide hidden form fields, highlight them, enable disabled form fields, remove input limits, remove JavaScript validation. There you are. You can just automatically do all those things. And now, when you go back to the browser, and you refresh this page, now it just puts the hidden field right there. It puts the hidden field there so you can change it. The field that was disabled is now enabled, and so on. This just makes it ridiculously easy. It automatically implements all these common features, turns them all off. Here's the script-based validation, so I can put in a big number and it doesn't care anymore. So that's another way of the many ways to prevent this. Now when you reload the page, it has modified the code on the way back down to make it remove all the common defenses. All right. So let's try a Kahoot. And I think I've got to go here.
There you can bypass server-side control.
Well, to bypass a server-side control, you have to find a vulnerability in the server. And that is possible if you find something like a way to inject code. And in fact, you'll do quite a lot of it in the projects in the Web Security Academy. The way you do it is you find some input that the server does not understand. Or you find another defect, like a way to inject code. Yes, you can bypass server-side controls. And that's mostly what you...
Both sides we can bypass.
Yes, both sides can be weak. Yeah, that's right. If the client-side controls are very easy to bypass, as we see.
We set up some prevention like both sides.
Well, yeah, what the server side is what you worry about. I mean, the client side, you could put defenses, but it doesn't really matter. The important thing is on the server side. And yes, on the server side, you want to detect attacks and block them, because There are standard ways to break in, and you'll be practicing all of them in the project.
Okay.
Yeah, good. All right. I see you can change the face after you log in. Good. All right. Maybe that's everybody. All right. So what's the most common form of authentication? Are these the right ones? I don't think this is in the lecture. I think I'm doing the wrong slides. Wait a minute now. I don't think, yeah, it's the wrong one. We're at 5A. There, that would make more sense. Let's try this one. They don't put the name of it here. All right, well, anyway. All right. That's the right one. Okay, good. All right. So why do web apps send data to the user and then expect the user to send it back? Yeah, there are two you're saying that's a mistake. All right, and that's the point. Simplifying coordination across multiple servers. That's often the easy way to move data from one server to the other, is to bounce it off the client. All right, which one of these is easy for the end user to modify without burden? The parameter is the easiest. You can modify the cookies anyway, in developer tools. You might be able to modify those other things too. But anyway, the URL parameter is the easiest thing. All right, so what do you have to do to make a compressed response readable in burp repeater? Yeah, get rid of the accept encoding in the request, and then it will not send it to you zipped. All right, how do you completely reload a page in Firefox? Shift refresh. All right.
We're also using Chrome or Edge. We're using
Yeah, I think it's the same there too. Yeah. Yeah. All right. All right. I know who two of them are. Cat, I don't think I know who that is. No, I have other instances of Tat. No, I don't. Oh, there. Okay, good. Tat's your real name. Good. All right. Fair enough. Good. So I do know who that is. Good. All right. So let's go back here. And, all right. So then there's browser extensions, which I say are less important than they used to be. Flash and Java client-side routines. These things are, for example, you have a casino app. People might be able to tamper with the state, bypass client-side controls, find a function that could give you illegitimate access to a server-side resource, find some way to receive information about other players, and these have really happened to a lot of online gambling apps. So if you have these things, Java applets and these old-fashioned things, Flash and Silverlight, all these work the same way. These were imitations of Java. They compile to bytecode and then execute in a virtual machine. So, and they often use serialized data that have complex data structures moved down as a block. So Java is the main one that's still in use, and you'll have these Java applets running in a sandbox in a Java virtual machine, and they're going to have Java serialized objects coming down. And it's just a blob of encoded data. So you see this blob of strange characters. This is the data, and you can run it through deesser, and it will unpack it and show you what it is. You just got an array here. It's just a bunch of data in there stored. It can be unpacked because by default, serialized object is not protected or encrypted. It's just serialized. In Python, there's a thing called pickle that does this too, just a way to serialize objects into one long string of data. So, all right, so you can find, if you want to penetrate these, you just need a serialization unpacker, and there are unpackers for all the common kinds of serialization, and then you can modify the data in the serialized data and see what it does and see if you can find a weakness where modifying that data has an unexpected effect. And one example I know well is Android apps. Here's the Bank of America Android app. You can download it, you can pull it from the phone and unpack it. And when you do, you can see all the source code of the app. It's largely not obfuscated. You can see parts of it are obfuscated here with things like just BS, BT, BU.smalley, but important things remain unobfuscated, like credit card details activity. And so you can easily, and the point is, this is the original Java code that will have put a username and password, and this is the bytecode, which is compiled down to bytecode, and it's very readable. It's almost as readable as the original code. This is compiled Java, is very much like the original source code. So we do this in the hacking mobile apps class. You can just modify by adding more code at the bytecode level, and now you can steal the credit card numbers out of it. Out of the app. You can make a modified app that looks the same and works the same, but it sends extra copies of the credit card number out where they shouldn't go. So this is the same kind of thing you're doing with web apps. Mobile apps are very much like web apps, and that's going to be related to the API stuff I'll show you perhaps later today. So without any obfuscation, you see all these folders containing different parts of the code, and when you run it through an obfuscator, ProGuard is the free obfuscator you get for Android apps, but it's really miserable. It changes a lot of things into like A, B, and C, but a lot of them stay readable. And I've never had any trouble finding important things to steal in so-called obfuscated apps with ProGuard. There are commercial obfuscators like -O that really scramble everything and make it much harder to read. Anyway, so to avoid these flaws, don't send critical data like prices from the client. you send a product ID from the client, and then you look up the price on the server. That's a more reasonable way to do it. If you must send important data from the client, then you're going to have to sign or encrypt it to make sure that the user cannot tamper with it. Even if you do that, you might be vulnerable to replay attacks or other attacks, or even if they cannot decrypt it, they might be able to use it. So it's risky, and you have to consider the consequences if you're going to do that. All the client-side validation methods cannot be trusted. You cannot control what happens in the client's browser. And all right, the only secure way to validate is on the server, and as we were talking earlier, even that might have flaws, but it's better than doing it on the client. And the other thing, of course, is if you get data that has been maliciously modified by the client, violating your client-side validation, you should detect that as suspicious, and you should log it and perhaps ban that client and perhaps freeze their account and things like that. You should not just let them try many times modified data. There should be a threshold. A sufficient amount of modified data should cause you to realize you're under attack and stop it. See, how would data such as social security numbers be handled? Well, what you might do to handle the social security number is you'd have client-side validation to make sure that it's only numbers and has the right number of digits, just so the user doesn't waste anybody's time with malformed data. And then when you send it to the server, then you would meaningfully compare it, say, to a list of known customers to see if you have a customer with that number or something. Yeah. But if you don't have anything to compare it with on the server, then the only thing you can do is make sure it has the right number of digits. But if that's important, you should verify it on the server. You shouldn't trust the validation that happened on the client. All right, so let's go look at the other 5B. All right. Godzilla shotgun. All right. All right. So which one of these is not compiled to bytecode? All right, HTML is the only one that isn't. All right, so what should you do if you receive data that violates client-side validation? The best thing to do is to stop the session. You know you're under attack. All right. All right, so how do you make data from the client trustworthy? Yeah, signing it is, with a good signature, can make it trustworthy. None of the other techniques can. All right. PB is run twice. SR, those look like real initials. And tap. Good. All right. Stop this recording.